Hey guys, it's Lemar. Today I'm going to be explaining the past periodic questions for mechanics. Okay, I'm only going to do the solving questions for obvious reasons. First thing we have to find the tangent of the velocity of the block at t equals 1 second. So, um, at 1 second, which is here, this is seconds, and here it's the velocity, or yeah, this is time. Here it's time, and here it's velocity. Okay, so this is time, sorry, I mean velocity and then time. This is v and this is t. Anyways, we said at time 1, so of course we're gonna take it as 1 and 2. They are x1, y1. Okay, now in the exam there was 2 points meeting, one here at 2 and 0.5 and one at 3 and 0. I'm gonna take 3 and 0 because taking 3 and 0 we don't have like a 0.5 or a point something, so it's easier to solve, easier and faster. We can also take this one, we will get the same answer, but I'm just gonna take the easier one. So now y2 minus y1 over x2 minus x1, you will get -1. Okay, now for this question, an object is dropped from rest in air heights of 100 meters. It will accelerate uniformly at 9 meters per second squared. How long does it take the object to stay airborne? So, um, we're gonna use 1 over 2. A is 9. T is what we're trying to find, so t squared plus, they said from rest, so v initial is equal to 0. So plus v initial is 0 and times t, it will be 0. So we just don't use it. So it's equal to 1 over 2. 180 equals to 1 over 2. A then t squared. So you put this on the calculator. When you put it on the calculator, you're gonna get 6.3. Okay. Now, they want the displacement. Displacement means they want the area. This is a trapezoid, so big base plus small base over 2 times height. The big base is 120 plus the small base, which is between here and here, so 30 over 2 times by the height, which is 18. You will get 1350. Now, a drone initially at 8 meters per second, if accelerating at 3 meters per second squared, the displacement in 3 seconds is. So, of course, we're going to use this formula. 1 over 2. A is 3. T squared plus 8 and then t. You will get, I think you will get 37.5. Let me just make sure. Yeah. Okay, now. For a body moving along a straight line at 40 meters per second undergoes a deceleration of 4 meters per second. Deceleration, it means -4, because they said deceleration, it means it's -4. Okay, what would be the distance traveled by the body in 10 seconds? So, of course, we're going to use 1 over 2. A t squared plus v initial, which is 40, plus 10. I mean times 10, which is equal to 200. Okay, they said the displacement is equal to 13 and x final is equal to 13, or x2 is equal to, x2 is equal to 7, or x final is equal to 7. what is x initial or x1? So we know that displacement is x equals to final minus initial, or you can say x2 minus x1. Okay, so displacement here is 13, and then the final here it was 7 minus x. Okay, move x to, yeah, move this to the other, move this there and move this there. So this will be 7 minus 13 equal to x equal to 7 minus 13. So x equal to -6. Okay, now accelerates from rest. An object accelerates from rest at 2 meters per second squared over a distance of 100. What's the final speed? So we're gonna use this v squared minus u squared equals to 2a delta x. They said final speed, so which is v squared, so we're gonna keep it x squared minus, they said from rest, so 0 squared equals to 2 and then 2 and distance of 100 meter, so 100. Okay, now you put it on the calculator, you will get 20. Okay, moving uniformly at 12.5 meter per second, decelerate uniformly and stop after 25 meters. So they want you to find the what's it called, the acceleration. So what you're gonna do is you're gonna use this formula, v squared minus u squared equals to 2a delta x. So v decelerates uniformly, it moves uniformly, so it starts uniformly at, yeah, okay, 12.5 squared minus 0 squared equals to 2a times 25. So 50a equals to what's 12.5 squared? 156.25 divided by 50. So 3a equals to 3.125. Okay. They want the position of the body. Okay, here. A body moves along a directed straight line at constant velocity of 6 meters per second in the positive sense at time t equals 2. The body was at position x equal to -4. The position of the body at t equals 8 is how many meters? Okay. We know that velocity is equal to x2 minus x1 over t2 minus t1. So here let's do this, which is t1, this is x1, this is t2, and this is the velocity. Okay, so 6 equals to x2 minus 4, it will become plus because it's already negative, over 8 minus 2. You put it on the calculator, you will get 32. But let me just make sure so I don't do anything wrong. Yeah, 32. Okay, now V equals 10 meters per second. After 10 seconds, it becomes 20. So initially it was 10, and then final became 20. So you will use V minus U over T. A equals V minus U over T. So 20 minus 10. Oh, guys, this is not after 10 seconds. This is 3 seconds. I wrote it wrong. I wrote it down wrong. Over 3. Yeah, also this is 22. So 22. So first thing, it was initially at 10. Finally at 22. So 22 minus 10 over 3, which is equal to 4. Guys, by the way, V, we say it V final, and U is V initial. Okay. Guys, by the way, also those questions came exact same in the exam. So in the finals, I think they would also come copy pasted the exact same, because those are questions from the exam. Okay. Now, from Rust, so initially it was 0, and then it became V final is equal to 30 at a rate of 3 meter per second. So we have to find the distance. Yeah, so we're gonna do V squared minus U squared equals to 2A delta X. This is 30 squared minus 0 squared equals to 2 times 3, and then delta X. Delta X is equal to 150. Now we have to find the time. So delta X equals to 1 over 2 AT squared plus V initial T. So here it will be 150 equal to 1 over 2 A, just 3, and T is what we're trying to find, plus this is 0. Okay, so it's gonna cancel. So T is equal to let me just check. It is 1 over 2, 3. Then, yeah, okay. Just need to check. Yeah, you will get 10. Okay, guys, that's it for the video.